Hello everybody, this is Mrs. Gabriel. I'll be presenting the phosphorus, hydrologic, and just a couple other little cycles in the shortest video that I can possibly get through with you. So you'll be seeing the slides that look like this often in many of my videos. These are the essential knowledge points that you need to know. The College Board has assigned me to make sure I cover so that when you take the exam in May, you are successful. So you can always look back at these when we're done the video. So the major reservoirs of phosphorus in the phosphorus cycle are rock and sediments. And these rocks and sediments have to contain phosphorus-bearing minerals. So let's follow part of the cycle. In one of the several possible paths, there's several paths you can see from the arrows, find where the phosphate rocks are in the diagram. It's right over here. These must be rocks that have phosphate minerals in them. Remember that. Follow the arrows. Rocks can either be weathered or they can be mined. Find both those arrows. Now let's follow the weathered arrow. So rocks can fall, get broken, or worn down. That's how a rock gets weathered. And these small broken pieces of solid phosphate can dissolve in water, often rainwater or lake or pond or any other body of water. Then the dissolved phosphate is used by plants. And oh, plants love phosphorus. It's a nutrient for them. And consumers then eat the plants. Then the consumers die or they poop, and they or their poop decomposes. And the decomposition process transfers more phosphorus in the runoff and in the water, et cetera, et cetera. That's one pathway. So you can pause and you can look at more if you want. Another pathway is where precipitates out of water solution to form phosphate sediments, and these sediments over time become rocks. Now for these rocks to get exposed to wind and rain and gravity and weather again, plate tectonic forces or geological forces need to come into play, and that's a whole other chapter. Okay, so these bullets are the big takeaway for what I just reviewed. And what I didn't really point out is there is no atmospheric part to this cycle. This is kind of unique, so don't forget what I have highlighted there in yellow. Remember that we need to get really comfortable with applying scientific knowledge to models and diagrams. So let's practice again. I want you to read number 1 here. Producers take up phosphate and assimilate into tissue. Now look in the diagram. Where is that modeled? Pause if you have to. And this is how you should study. Practice again and again. Now look at number 2. Here's a fact. Phosphorus is not soluble in water, so it precipitates and buries. Now find this as it would be demonstrated in the model. And then pause and then do 3, 4, and 5 to review the facts that are listed here and practice by looking at the model. All right, we're going to do it again. I'm going to demonstrate how I study these facts out loud. So I might read number 4 and number 5. So man-made fertilizers and phosphates to aquatic systems, right? So I'm thinking of a fertilizer sprayed on the soil to feed my plants with nutrients and help them grow stronger. They water. I water them with the fertilizer and the water just runs downhill. And the dirty phosphate-laden water, this dirty polluted water, is what we call runoff. It doesn't always have to be dirty, but in this case it is. That runoff runs downhill into the road and then into streams and rivers. Now look at all the things we use phosphates for. Industry, detergents for washing our clothes, dishes, cars, food additives as salts to feed farms, and of course, it's a main star ingredient in fertilizers. And all of these eventually transform and flow into the water or soil. So not naturally, but anthropogenically, that's human caused. We can add a lot of phosphorus to our water and soil, and this can be bad. It causes like water pollution. And these are, I don't know why my thing's not showing up. Oh, there it is. Okay, these are the things that I wanted to tell you about. Industry detergents, food additives, and fertilizers. That's what we use phosphate for. So let's review. Phosphorus has major reservoirs, mostly in rocks and sediments, and not in the atmosphere. And that means phosphorus from the ocean to the land is kind of missing that little pathway. I mean, the sediments buried in the deep ocean aren't being geologically uplifted every day. So our land plants, those terrestrial systems, don't get lots of phosphate quickly, naturally. And that's why we mine for those rocks that contain it. Then we humans quickly process the rock to transform the phosphorus into a usable form. And this usable form would be where on the chart? It would be fertilizers. Humans disrupt this cycle by making and using fertilizer. Naturally, this would be a very slow cycle, and phosphorus, therefore, is often a limiting factor for the successful growth of plants in an ecosystem. All right, there's other nutrients which move around and within cycles. They interact big time with the hydrologic cycle, and sulfur is one of them. Sulfur is an important macronutrient that helps plants and animals use oxygen. We really, really need it. It also has a little to do with cellular processes. So these are some of the big things that you need to know about sulfur in the biosphere. The sulfur cycle is similar to the phosphorus cycle, except sulfur-bearing minerals are in coal. Coal is right down here. Coal has sulfur in it. Coal and petroleum, which we use for like gasoline, also has some sulfur in it. We burn this stuff and then we add sulfur to the atmosphere. When we add it to the atmosphere, it can come down as acid rain or acid deposition, and you know this isn't good. Oh, and side note, a little sulfur does get emitted from volcanic eruptions. A few other macronutrients involved in small cycles are calcium, magnesium, and potassium. And they are important for us and all living things because they regulate our cellular processes. I'm not going to read this slide of notes about these other important minerals who are incorporated into other cycles, so you make sure that you pause and read these. And K, by the way, stands for potassium. K is for potassium. Okay, now we're going to move on to the hydrologic cycle. This is a biggie, and here are the essential knowledge points that you need to know. So luckily you have some background on this cycle already from middle school, and most of this will be review. So the most important thing to take away is that the hydrologic cycle is powered by the sun. It moves through, the water moves through the cycle in a solid, gas, or liquid form. Most water is in the ocean reservoir, followed by ice caps and groundwater. So the three big words to know how to use that are probably new for you are transpiration, evapotranspiration, and runoff. So let's kind of like think about these while you look at the definitions and you look at the diagram. So read the definition for transpiration. Now the typical plant, including any found in a landscape in your yard, it absorbs water from the soil through its roots. You know that. The water is then used for metabolic and physiologic functions. The water eventually is released back to the atmosphere as vapor, just as you release water vapor when you breathe. You know that from like breathing on a window. Plants do too, but we don't call it breathing with plants. We call it transpiring. This picture shows water vapor transpired from plant leaves after a plastic bag has been tied around the stem for about an hour. Now, if the bag had been like wrapped around the soil below it too, then even more water vapor would have been released because water also evaporates from the soil. Plants put roots down into the soil and they draw the water up, and the nutrients go up into the stems and leaves, and then some of this water is returned to the air by transpiration. Now this uptake of water at the roots, transport of water through plant tissue, and the release of vapor by leaves is known as transpiration. Water also evaporates directly into the atmosphere from soil in the vicinity of the plant, and any dew or droplets of water present on stems and leaves of the plant eventually evaporate right off right off the plant, just evaporates right off it. And so scientists refer to that combination of all those things, evaporation and transpiration together, as evapotranspiration. I really like this diagram, so let's follow the paths. Find the cloud that's raining. So it shows how the precipitation to the land runs off the surface, run off. And the ocean also gets water from precipitation over on your right, so pay attention, like just so you know. Follow arrows. Get used to following the arrows and getting comfortable with diagrams. Okay, so back to the left, back to the mountain. So the rainwater only runs off because the hill or the mountain, it's got to run downhill, right, because of gravity. Now this is the part you may not have learned as much about. From there, this water can run down the surface of Earth into streams, into a lake, or back into the ocean, but it can also infiltrate its way under the surface into the soils and into groundwater. Guys, we have a lot of groundwater underneath us. Now, as you can see, the subsurface flow through soils is like purple, and plants can access water that way, but then that other water is deeper, the groundwater. And this water interacts closely, with streams and ponds and lakes also. So as you can see, it also goes back to the atmosphere by evaporation and transpiration. Let's look at another diagram showing water cycles. So let's follow evaporating water. The liquid water from the ocean or a lake or even a puddle, heck, even you sweating, this liquid water can change to gas where it becomes lighter. That's evaporation. These gas water molecules either float up around in the air or they stay close by adding humidity to your airspace. And some are captured in rising masses of air where it gets real cold as it rises. And then, like, follow the arrows, the gas water molecules then condense into a liquid. And that condensed liquid then falls back to Earth as precipitation, where it's either running off into lakes, streams, or the ocean, or it's infiltrated into the ground in another reservoir of groundwater. And meanwhile, plant roots may take up some of that water, grabbing it from the ground or the surface or even the air. So that's it. You should easily understand these biogeochemical cycles now. Before I show the answers on this slide, I want you to pause, use your notes or your brain, and guess the 3 roots. One is returned to the atmosphere. One is absorbed by soil through infiltration. And one is moving across the surface through runoff. Okay, now this course is about learning how humans impact Earth's natural systems. So before I show one example answer of many possible responses, I want you to use your notes or brain again to explain 3 ways that humans impact the hydrologic cycle. Pause, and then when you're ready, check. I'm not going to read this to you. You can read it to yourself. But one then leads to the other, which can lead to the other, and there can be other answers that you could have given for human impacts. All right, now in APES, you have to start applying your math skills to the science class. You're going to be allowed to use graphing calculators for the actual exam, but it will be timed, and you're going to need to write out your problem, your equation with units. So here's a scenario that I want you to solve, and although it's very easy, it's much simpler and easier than the actual test question, it is a nice warm-up. So I want you to pause, and I want you to give yourself only like 2 minutes to try to write out the problems and solve, then check your answers. And number 2's coming, so notice I write out the problem, I have my units, and then my answer. I write out the problem, I have my units with the problem, and then my answer. All right, well, that's enough on cycles. So this is Mrs. Gabriel signing out. Have a great day, guys.